Welcome to the Explainer. So, if you've ever found yourself staring at a terminal window at, say, 11 p.m., just mass copying commands from Stack Overflow, and absolutely terrified of accidentally deleting your entire project, well, you are in the exact right place. Today, we're going into full tutorial mode. We're going to completely demystify Git and GitHub. We're taking you from an absolute beginner, making your very first local commit, all the way up to seamless cloud collaboration.
Okay, let's dive right into our roadmap for this mini course. We'll be hitting 5 key areas. First, Git versus GitHub. Second, core concepts and architecture. Third, local Git commands. Fourth, collaborating in the cloud. And finally, some hands-on exercises and review questions to lock it all in.
All right, let's kick things off with Section 1, Git versus GitHub, the basics.
A lot of people actually use these terms interchangeably, but they are completely distinct. It's like this. Think of Git as the camera that takes the snapshot of your code. GitHub? Well, that's Instagram, the platform where you actually host and share those snapshots with the world. Or, hey, if you prefer, Git is the coffee itself, and GitHub is the coffee shop where that coffee is served up and shared with the community. Basically, Git is the local tool recording the work right there on your machine, while GitHub is the centralized online platform for sharing it.
So, where did this metaphorical camera even come from? Well, Git was actually created by Linus Torvalds. Yep, the exact same brilliant mind behind the Linux operating system. He built it as a version control system to effortlessly keep track of multiple versions of files 24/7, 365 days a year. It's kind of fascinating that the creator of Linux built this entire system for one incredibly simple reason: to ensure you literally never lose a file or accidentally overwrite important client code ever again. It tracks what changed, exactly when it changed, and who changed it. A real game changer.
Moving right along to Section 2, Core Concepts and Architecture.
Now, what's really interesting about this next part is that understanding the underlying architecture makes the actual commands finally make sense. The absolute crucial point here is understanding the commit. Actually, scratch everything you think you know for a second. Git is basically a database, and the fundamental unit of that database is this complete snapshot, not just the changes. A commit is a complete photograph of your entire project at one specific moment in time. It stores a pointer to that complete snapshot, some metadata, like who created it and when, and crucially, a pointer to the parent commit. This acts like a historical breadcrumb trail so Git knows exactly where it fits in the project's entire history.
But before you can actually take that snapshot, you have to, do the work. Enter the working directory. This is your local workspace. It holds the current state of your project that Git hasn't quite yet been told to track. So the key takeaway here is that this is where you actually write your code, tweak your text files, or design your graphics before doing anything else.
Once you've made those changes, they don't just immediately become a commit. Nope, they go to the staging area, which is sometimes called the index. You can really think of this as an explicit checkpoint or a draft space. It gives you all the flexibility in the world to decide exactly what goes into your next version. It basically lets you review and fine-tune your changes before they become a permanent part of your project's history.
And finally, we have the repository. Once your changes make it through the staging area and you officially commit them, they are securely stored right here. The repository is basically like a giant digital cabinet. All the versions of your files and their complete, extensive change history are permanently locked into this historical record on your machine.
Okay, let's jump into Section 3, Local Git Commands, using Git locally.
Take a close look at the progression of commands here on the screen. You can actually see the workflow happening right in front of you. Creating a file, adding it, committing it, and then checking the log to see that secure snapshot officially locked into the project's history.
To get those exact results, you're going to use these 4 core commands. First up, git init. This initiates a brand new repository so you can start tracking. Second, git add to move your modified files out of your working directory and into that staging area. Third, git commit -m, along with a descriptive message to actually save that snapshot. And finally, git log to view your project's history. I highly recommend you just pause this explainer right here and memorize this sequential workflow because you are going to use it every single day. For sure.
But hey, look, we all make mistakes. Maybe you committed a file you really didn't mean to. That is exactly where commands like git reset --soft come in to save the day. This lets you gently roll back to a previous commit without actually losing the work in your working directory. Trust me, knowing how to use this to roll back to a previous version without losing your hard work, it will absolutely save you from late-night panic.
All right, Section 4, Collaborating in the Cloud and Pushing to GitHub.
So a lot of the time, you won't be starting a project completely from scratch. When you join a new company, or maybe you just find a super cool open source project, you're going to use the clone command to download their repository directly to your machine. As you can see, GitHub gives you a specific URL. You just copy that, run git clone right in your terminal, and boom, it pulls the entire remote repository down locally so you can start contributing right away.
But why use GitHub at all? Well, beyond just acting as a central cloud server for your backups, GitHub massively expedites software development and enables incredibly seamless team collaboration. It basically operates like a giant digital lemonade stand where developers can share, fork, and collaborate on free open-source code globally. Plus, it gives you some seriously powerful project management tools like issues for tracking bugs.
Now, when you're collaborating with others, the single most important concept is the pull request. A pull request is simply a formal request to review, discuss, and possibly merge proposed changes from one branch into another target branch, usually the main project. This is absolutely the cornerstone of the GitHub flow. It ensures that team members can securely review your work, offer some feedback, and approve it way before it ever impacts the main codebase.
And that brings us to our final chapter, Section 5, Exercises and Review Questions. Time to put it all into practice.
Because we all know we learn best by doing, here are your local workflow exercises. I really want you to pause this explainer right now, open up your terminal, and physically complete these 5 steps to lock in that muscle memory. Go ahead and initialize that repo, create and commit a new file, modify it, practice renaming it, and finally delete it and commit that deletion, just to see firsthand how Git tracks every single change.
Okay, welcome back. Let's do a really quick review. If someone were to ask you to explain the difference between Git and GitHub right now, what analogy would you use? Take a second to see if you can recall the camera versus Instagram analogy to really cement that foundational concept. Just remember, Git is the local tool taking the picture, and GitHub is the platform sharing it with the world.
All right, next up. When you create a Git commit, what 3 specific pieces of information are permanently stored in that snapshot? Remember that it's so much more than just the file changes. It relies on metadata and pointers to build a really cohesive history. You've got the complete snapshot pointer, the metadata, like the author and date, and of course, the parent pointer.
And finally, let's look at the big picture. If Git completely eliminates the fear of losing your code, how does this change the way humanity builds complex technology together? I'm going to leave you with that provocative thought. Version control isn't just some boring technical tool. It's the ultimate safety net empowering global innovation. It literally allows thousands of minds to collaborate seamlessly without fear. Thank you so much for joining me on this journey through Git and GitHub. Keep learning, keep committing, and I'll see you in the next one.